learn basics of networking. So parallelly or maybe later also we can try. Just simply go to the skills for all. Okay. Skills for all. Oh, there are going to maintenance. Skills for all will be unavailable to the schedule on 22 April through 23 April. Yeah, it is 28. They want to update servers data image or taken a backup, so they will put it in a maintenance mode. Maintenance is completed, but still notification is there. Okay. So this is Cisco related one only. What are the courses here all are free. You can learn anytime, any. So you can see networking basics. My preference is go to networking essentials. This is showing only networking. This is Python. Computer basic hardware.
बड़े ने उन्हें तो यार
Network addresses and basic troubleshooting. These are cyber threatening kind of stuff. This is networking essentials. So maybe you can learn parallelly if you have it. Otherwise, not only networking essential, there are some other courses, including Python is also there. Okay, it's not a video material, guys. It's not a video materials. Like you watch it and forget it. It is not there. You have to read each and everything. There is a test for each module. Okay, and there is a final test also there. And once you are completed, you will get a learning kind of certificate from the Cisco Academy. Okay. So you learn so many things from it. It is 70 hours means daily you spend 1 hour also. Now, 1 hour later it will be completed. It is one of the free resource from directly Cisco Academy. Or you want to go for a troubleshooting part, only troubleshooting part I want to learn, then also you can learn about a troubleshooting part also. Okay. This is basics. So you have to search one by one. Operating system basics is there, hardware basics also there. Okay. This is networking, address and basic troubleshooting kind of stuff. At least list. You take this one also, it is useful for you. Okay. So that's one point I want to tell. So this, a lot of resources are available nowadays to learn some things. Okay, got it? This is my networking PPT. I will share the link to you also. So this is the link. So you can find, and also I will give it in here. But notes is better because it's a notes. I will not only this, some are changes. Pattern will be different from here to the diagrams and pictures are different. Just I want to give you overview what is we are going to learn in the networking basics. First of all, network. And what is a networking? What is internetwork? What is internetworking? How this network and internetworking means how the connections are there. Okay, so about different types of networks like LAN, CAN, MAN, WAN. What is those things depends upon geographical range, how this network is divided or defined. Next, we will going to learn about a small office, home office, and in that one, what are the devices we use it, how we are connected in our home or office to communicate in the network and getting internet, how this thing is there. So that is also we will discuss. What about a NIC? What is a NICs we use in the network? And what is MAC address? What is an IP address? What is different cables we use in the networking? What type of cables we use in the regular network? Okay, and there's some details and devices used in a network like a hub, switches, routers, modem kind of devices we are using the network. So what is the use of those devices and their differences and some specifications. So what is a router? Okay, and here it's same small office, home office. Different topologies we learn. Bus topology, ring topology, mesh topology, star topology, hybrid topologies and all. About IP address and MAC address and IPv4 and IPv6 and about IPv4 how IP address is there, what are their IP address classes are there, okay, how to recognize which class of IP address and what is their subnet mask, what is a subnet mask, okay, and what is private IP, what is a public IP addresses, what is NATPAD technique, okay, what is APIPA. What are the OSA model means? OSA model, what are the 7 layers in that OSA model and what is the use of those models? What is the use of these layers? Why should we learn and what is there it inside? Okay, and different protocols and their port numbers, and comparison between your OS layers and TCP/IP layers. So using OS layer, how can we troubleshoot our network? And what is the use of this networking commands? How it is useful for troubleshooting and do certain tasks. Okay. Ping command, using ping command, how can we troubleshoot and other commands we use in the networking. And next is possible, I will try for a network troubleshooting. So it is a lengthy topic, guys. Very important is how much lengthy of it is. If you study daily put a 15 minutes to half an hour. Earlier I said half an hour for every batch. Even they cannot able to afford a half an hour. So end of the classes, they will ask us, sir, how to do it. Give me some important topics. We are learning not even a 5 topics in our training. Not even a 5 topics. Service desk, networking basics, hardware basics, operating system basics. It means totally 3. Plus additionally, what is a cloud, what is VPN, what is Outlook, and that is it's small topics. Not even a 1 day topic also. Okay, but people are unable to study complete before interview. So 1 day before interview, they will get a remember we have to study. Okay. So don't do like that, guys. So study daily. Okay, videos are we have a backup purpose. Are you missing some point? Some people are having a problem with the network connectivity. So for them, backup purpose, videos are there. If you have any doubt or you want to check some point in it, you can go through videos. That's okay. Okay, but study daily. So watching is one side, but important is reading. After reading, practice answering. Practice answering. Put yourself a question. take it as a question and explain to yourself. If you practice, so you can become a more spoken person. You can easily tell any kind of answer and you can analyze that thing. Okay. So when you get a chance to learn guys, that is the most important. If you are not having any chance to learn something, it's okay, no problem. We'll see that one later. Okay. But when you got a chance to learn, so try to learn, do it. So once you got a subject, mainly you strong with the basics, you can learn any subject. Want to do a cloud, AWS cloud architecture, you can do it very easily because so the basics which we are discussing, that is also helpful for everything. Okay, that's the point. So can we start?
Yes, sir.
Yes, sir. Yes, sir.
Sir.
Yes, sir.
Yes, sir.
Right. The first one is what is a network? Interconnection of two or more devices is called a network. What is interconnection? I have a device. For example, generally network means first thing will comes in the mind is computer networks. But why he said it is a devices? So why? Because not only nowadays computers, also different devices, including mobile phones, your smart TVs. Okay. Mute. Okay. So either you connect a device to device directly, or you are connecting through some hub or a switch. So whatsoever it is a single network. These devices can able to communicate each other. So A want to communicate B, so they will communicate each other. But first important is connectivity. The connectivity what we are calling as a network. Interconnection of two or more devices is called a network. So this is a network, one network. For easy to make, I put A1, B1, C1, and this is a one network. It's a single segment network. It is a network. Same way, I have another network, separate network is there. Sorry. Guys, understand this point? So network. Interconnection of two or more devices. If A can able to communicate to B1, A1 can able to communicate B1. Means it is networking. Communication between interconnected devices. So there is a communication between these devices. So it is communication between the devices called a networking. Communication between two or more interconnected devices is called a networking. Got it?
Yes, sir.
So I have a devices like this. So I have a separate network. So this one I put a A2, B2, C2. This is separate network 2. Okay. So this is another network, means interconnection of these devices, it become a one network. Interconnection of these devices, it's a network. Okay. Now, these can able to communicate each other means there is a networking. Communication between the devices is called a networking. So this is two separate networks. I want to connect these networks. These are all two different networks. I want to make them connected, these separate networks together. Okay. Like this. So here I am using a device called a router, which is Internetworking device. This router is a Internetworking device. It means it make a connectivity and as well as a communication between different networks. So I make a connection between different networks. First of all, connection. First need a connection, right? Then communication. So internetwork is a connection of two or more networks. Two or more networks. Now it is internetwork. I connected to two different networks or three different networks or four different networks. So it is interconnection of means connection of two or more different networks called the internetwork. Okay. Next one. Internetworking means communication between different networks. For example, this C1 want to communicate it to A2. The C1 send a packet like this through router to this router and finally it can reach. Means there is a communication between these two networks. In this network devices can able to communicate each other from this network to this network. This is called a internetworking. What is internetworking means communication between different networks. Same diagram only have written. If I start, actually I will draw all these things in generally.
So what is switch hub is it?
Switch and hub, very good. Hub or a switch. Hub is a device and switch is also a device to connect devices in the star topology. Okay, to make a LAN connectivity, a simple LAN connectivity, or to connect devices to communicate in the network, within the network, this hub or a hub, you can use it or you can use a switch also. This is a router. Router is an internetworking device. Router is an internetworking device to make a communication between different networks. So here it is. We are using a hub and switch devices in a LAN communication local network in a single segment networks. Means it's a single network is communicate using either hub device or a switch device. When you want to communicate between different networks, so we need a router. If you want to communicate between different networks, so we need a router. So router is an internetworking device which make a communication between different networks. Okay guys, understand up to this point?
Yes, sir. Yes, got it.
Right.
Yes, sir.
What is this? Mainly in a network. Network means connectivity. Network means connectivity. Either it is internetwork or just a network. It is mainly connectivity. To one, we have to connect the devices. Then only we can able to communicate. So to connect the devices, we need a connecting devices like a hub, switches, router kind of stuff. We need a connectivity devices, and we need a NICs. So one devices has to connect. It should have a NIC, a network interface card. For example, your laptop, your mobile phones, your PCs having a NICs to connect in the network. Either it is wide type of network or wireless type of network. They have their own built-in NICs are there. With NIC only, we can able to connect from your devices to other device like a hub or switches or Wi-Fi routers, Wi-Fi access points. You may need a cables to connect a devices, right? That is a network. A network means connectivity. Networking means communication. Okay. Networking means communication between the devices. To communicate between two devices, to communicate, first important is connectivity. First important is there should be a connectivity, of course. Next one is in networking, how they will communicate, what they will communicate, what is the meaning of communication. Meaning of communication, I am communicating to you, you are communicating to me. So means what I am communicating, I shared my screen, I'm explaining, I'm talking, you are receiving that information. So that's what I'm communication. Means I'm sending a message, I'm sharing my screen, okay? I'm sharing my notes through WhatsApp or maybe through some web portal, sharing information, sharing a resources, sharing information, sharing of resources or sharing of data, okay? Or giving some information to other devices, right? So this is what communication means. To communicate in the network, first there need a connectivity, means network must be there, and next we should have a protocols. What is the user protocol? I want to access a website, I need a HTTP protocol. See, HTTP protocol to access a website. HTTP or HTTPS protocol required to access a network. Next.
Sir, hello, sir. Why we use once HTTP and HTTPS, sir? Means in some websites.
I got it. So that's actually very good question and important question. Definitely, I will tell about what is the difference between HTTP and HTTPS. When we use HTTP, First of all, HTTP used to access web pages. There is a web server and you are a client VC. So through web browser, so you are trying to contact a web server. Right, in web browser only, we are trying to access a website, right? Not in other means. Like generally, web browser uses to access web pages from the web server. How web server will understand what is your request based on your protocol, HTTP protocol. Once it is received your request, web server will give you data with a HTTP response. So this is for understanding what type of communication HTTP hypertext transmission protocol to access the web pages from the web server. Then what is this HTTPS? HTTPS also same protocol. It is also used for accessing web pages also. But what is the difference? Data in the HTTP is a plain format, no encryption in it. Data is not encrypted. If someone is trying to capture your data in your LAN network or in internet, or someone trying to capture what is the data you are transmitting from client to server or server to client. So he can able to capture your data. He can manipulate the data and he can deliver some another data to it. Okay. So that is the possibility with the HTTP. Because data is not encrypted. HTTPS, whatever the data you are sending and receiving, it is encrypted. If you open a WhatsApp, it shows end-to-end encryption. Means data what is displaying on your mobile, it is displaying to you, right? But when you are sending and receiving, that while it is traveling through this network, internet, data is encrypted. Okay, when you are send a message, you can able to see the message, but once it is out of your mobile phone, out of your application, the data is out of your application itself, data is encrypted. Same way, HTTPS, when you are sending and receiving a data, HTTPS, they encrypt your data. And where we use this HTTPS? Where we use this HTTPS? Compulsory for banking websites, email access. You open a Gmail account, compulsory it is there. Okay, and most of the website nowadays are HTTPS only because those more threats are there. So, but compulsory banking, email, social media, okay, or anywhere we use some sensitive data, it is there. So compulsory use the HTTPS. It may not required within the LAN communication, but we are using mostly it is through internet, compulsory HTTPS. It encrypts your data. Got it, guys? HTTPS.
Yes, sir. Yes, got it.
Very good.
Yes, sir.
Okay, here it is. Not only these protocols, guys, there is so many type of protocols to communicate in the networking. Next one is a logical addressing. Of course, you want to communicate from one device to another device. They need an address, right? You want to send a mail to someone, you need a email address. Same way, one system is you are communicating from one system to another system, another device, another server you are communicating. So all communications through IP addresses only. So that is a logical address. So compulsory to communicate in the network. Okay, for communication purpose, important is logical addressing and protocols. These two are good points to enter here. We'll see remaining sizing, resizing. Oh, sizing, resizing problem is there. That we'll see. Guys, there is a two topologies, physical topology and logical topology. Physical topology and logical topology. So why this much gap it is creating? Somewhat not somewhat also, but it's okay. So what we can see. because these two are attached lines only. So what is a physical topology? The way the devices are connected. So you are having a devices, you have a computers or something, like you are connecting, the way you are connecting, how you are connecting, that is a physical topologies. What is a logical topologies? Means how you configure this logical addressing. Logical topology depends upon how you configure this logical address, means IP address configuration. Physical topology means how you connected a devices. Okay, there is a different type of physical topologies. Important physical topologies, traditional way: bus topology, ring topology, mesh topology, and star topology. And of course, there is a hybrid topology is also there, and point-to-point and multi-point topologies. Some additional topologies also there, like a tree topology kind of stuff is also. Okay. So I am copy pasted, guys, because time saving. Okay. So one is a time saving. Second one is, don't worry, I will draw everything on this one only. In paintbrush, one by one I will draw. Okay, once we completed these topologies, I'll give you a break. I have a devices. Guys, are you able to hear? Voice is clear?
Yes, sir.
Yes, sir.
Yes, sir.
So,
Yes, sir.
I have a devices.
Yes, sir.
Very good. I have a devices, and I connected all these devices to a backbone wire. To a backbone wire. So these devices are communicating through this backbone wire only. These devices are communicating through this backbone wire only. Okay. So it is very easy to configure and very cheaper solution. It is very easy to configure and very cheaper solution, because you need a main cable. Okay. So mostly that time they use a coaxial cable. Coaxial cable. Coaxial cable they use it. So this is our main backbone wire. Devices are connected to this one. So devices will communicate it through this backbone wire only. So all communications through single cable. So that will be channelized to not to confuse. But it consumes lot of bandwidth, means, it is a concept like a old cable TV type. Means there is a cable TV station. So they will send a signal, which is off duplex mode signal, a simplex mode signal it is. So they will send a signal. So one main backbone wire is there. From that one, so they have taken a connectivity to multiple devices. Okay, it is very simple to configure and a cheaper solution, but problem is problems also there. But before that one, we should put a name on it. This is a bus topology. This type of topology, physical topology, we call it as a bus topologies. Okay, so what is the problem? Just in case, if this wire is broken in some point, so further communication stop. AB communicate each other, but AB cannot communicate it to CND. Even CND also may not be communicate because the power source is disconnected. Okay, so wherever any issue is occur, when a cable is got certain issue, problem, any disconnection is happened, further communication will stops. Okay, one set of devices cannot communicate another side of devices. And difficult to troubleshoot. Difficult to troubleshoot. Why difficult? Because it's a backbone wire and you have to check entire cable. So where the cable broken is occur. So you have to check from starting to ending where the cable issues occur. Again, you have to do some work on it to make it connectivity. But direct cable is different, and once it is cut, you cannot replace entire cable, right? So you have to repair it. If you repair it, and it is a may generate some other problems. Simple to say, the devices are connected to a single backbone cable, and devices communicating through that backbone cable only. So further details in the PPT, guys. So you can check from the lines, but I'm telling orally what it is. Understand what is the, yeah. Guys, understand bus topology?
Yes, 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 sir.
Yes, sir.
So in this case, this is, we are connecting a device. For example, these are the device names A and B, C, D. In this topology, we are connecting one device to another device, and that device is connected to another device. A is connected to B, B is connected to C, C is connected to D, D is connected to E, E is again connected to A. Means one device is connected to another device, other device is connected to another device. Like that, the last device is connected to the first device. It is like a look like a ring. It is look like a ring. Like this. Okay, so okay, so 1 second. Guys, devices, one device is connected to other device is connected to another device, and last device is connected to first device. This type of topology called a ring topology. In this one, it will work either clockwise direction or anti-clockwise direction. It means if A want to send a packet to D, A to D communication. Okay, A send a packet to B and B to C, C to D. How this is communicated. And D want to communicate it to A, D to A, D to E, E to A. So it is either it is clockwise direction or anti-clockwise direction it will communicate. How it will now depends upon the algorithms, programming. Okay, so how these devices should be communicate. So that should be programming each and every device, the way it should be communicate. Okay, so the entire path, the entire thing is they will program it inside. Okay, so it is also simple to connect. Okay, but what are the challenges? You will get it. For example, if this link is down, B to C link is down. So A to D communication means A can communicate it to B but no other further communication. C can communicate it to A, but A cannot communicate it to C. A cannot communicate it to C. Okay, if this link is down. Second one is if device is down, okay, device is not working, device is down, same problem. A can communicate up to B, but no further communication. D can send a packet to A, but A cannot send a packet to D. If one of the device or a wire is down, so further communication is stopped. So for that purpose, what these people done is they added a additional line like this. This is a double ring, means one line clockwise and the line anti-clockwise, means A want to send a packet to B, A to B. Okay, so it can be sent like this. C to A, C to A, it can be sent like this. A to C, it can be sent like this. Okay, so it's a benefit of what is double ring topology means. Once one line it works in a clockwise, another is anti-clockwise. So they will both calculate which is the nearest path. So based on it is communicate. That is a double ring topology. Even one link is down, also communication is going on. If device is down, communication also going on, means either this side or that side it will be communicated. So that is the benefit of double ring topology. Okay, even one device is down, so it has another path to communicate. So no problem, it will communicate. What is another challenge is this is difficult to scale. What is scale? You can increase your infrastructure size. Scaling means you can keep adding your devices. Very simple in this line. Okay, we will as per our topic. Okay, scaling means the ability to increase. Okay, scaling possibilities there means ability to increase your infrastructure size or maybe divide number of devices like that. Okay, so it's difficult to scale. Why? Because of if you are adding one more device, again I have to do all calculations and algorithms I have to implement. Already once it is implemented, good. But if you are adding one more devices, it's difficult. Difficult to troubleshoot also. You have to find further communication stuff means communication is there, not there. We don't understand clearly. It is a link problem or system is problem or maybe another problem, maybe protocols problem. Okay, we don't understand in the ring topologies. Okay, this is ring topology. Let's understand.
Yes, sir.
Yes, sir.
Okay, good. So here it is. Every device is connected to all other devices. Every device is connected to all other devices. Which topology it is? Any guesses?
Star topology. Star topology.
Problem with this topology is just for convenience purpose, people write like a star, but it is not a star topology, guys. Okay, so remember that one. It is not a star topology.
Mesh
It is
topology.
a mesh topology. Very good.
Mesh topology.
Very good. Mesh topology. It is a mesh topology. Even sometimes in college, the professor because it is look like a star, and it's a, he said it is a star topology. Even my lecturers also done mistakes. Okay. So later we seen the real CCNA part, then we understand which one is star and which one is mesh. What is a mesh topology, guys? Every device is connected to all other devices. Mesh topology is connected to every device is connected to all other devices. First one. And it is a redundant. Redundant means if this link is down, no problem, remaining communication is going on. So it's not depends upon the remaining communication, not depends upon this link. It is remaining communication is going on. A to C communication, A to D communication, A to E communication, C to B communication, D to B communication is there. For example, this device is down. Only this device we cannot communicate. All other devices we can communicate. Okay, all other devices we can communicate. So that's it is a redundant, means one path is not there, no problem, other paths are available. Understand? Guys, bus topologies, ring topologies, nowadays we don't use any place, small network or big network, we don't use bus topology and ring topologies because it's there earlier, now it is not there. Okay. Mesh topologies also we don't use it. We don't use mesh topologies also. Okay. But why I said mesh topology separately? Of course, mesh topology is also used in a core level, means servers, you have a 10 servers are there. They put these 10 servers need a redundancy part. One server fail, no problem, other server is there. SAN type of storage networks, storage area network, SAN means storage devices are there, storage servers are there, they should connect each other. If one server is down, no problem, other server can able to give you a service. One storage device is down, no problem, other storage device can able to give you the storage services. In that places, this mesh topology is useful. Core networking, there is a 5-6 routers are there, core big routers are there. One router is down, other router will take care of this path. Okay, other router will take care of that path. To make it much easier, that's a mesh topology. In regular network, we don't use mesh topology. Why? Because of you take a small office, 30 computers, 50 computers, 100 computers. If you want to connect like this, it is become more complex. Mesh topology is a more complex topology. It's a complex, not simple. Mesh topology is a complex topology and difficult to troubleshoot. You don't know which wire, where it is ended, where it is connected, which path is not communicating. Until unless you got a big problem, then only we know there is a problem. Okay, then only we know there is a problem. And number of devices increases, complexity increases. Difficult to scale, very difficult to scale. Scale means again ability to add, ability to increase kind of stuff, right? If I add one more device, then see how many connections I have to do it. Like this, every day two systems are increasing, one system is increasing. Every day I have to go to market and buy a NIC and cables and connect it. Okay, so it's very difficult to scale. It is complex. Is it not difficult to troubleshoot? I understand. But it is a redundant. It means a wire is broken or a device is down, further communication is gone. So this is mesh topology. this is, there is a centralized device. This centralized device can be a hub, or we can use a switch device. It can be a hub or a switch. And all these devices are connected to this hub or a switch. All these devices are connected to this hub or a switch. So this is centralized device. For example, this is A, P, C, B, P, C, D, E, F, G, H. And these devices are communicating, like A to B communication means A send a packet to this hub or a switch and B receive it from here. Means all communication is going through this centralized device only. All communications are going through this centralized device only. Okay. All these devices are communicating through this centralized device called a hub or a switch. It is very easy to configure. Again, it is very easy to configure and easy to troubleshoot, but not redundant as a mesh topology. In our regular LAN net communication, we use this topology. And what is this topology name?
Bus topology.
Star topology. Okay. This is our star topology. Okay. So what is the points? Devices all communicating through this centralized device only. It is very easy to configure, easy to troubleshoot, but no redundancy. So what is no redundancy? I will tell, but it is very good scalable. Okay, easy to scalable also. Easy to configure, easy to troubleshoot, easy to scale. Means we can add more number of devices in a single network, single segment network. Okay. So before going to that scaling part, I will tell issue. If this wire is broken, if this wire is link is disconnected, so A cannot able to communicate to anyone or anyone cannot able to communicate A, means A is disconnected. For example, this device is down, only this device cannot communicate. Remaining communication is going on. If link is down, only that particular device not communicate. If this device is down, so the only that particular devices cannot communicate. And if in case this centralized device is down, what will happen? Total communication is stopped. But easy to troubleshoot means you can, first of all, we can identify where is an issue. Is it a link related, device related, or centralized device related? We can easily understand because of these devices having LED indications. It will tell you link status. So that is placement. Guys, this is my another devices are connected to a switch or a hub are connected like this. Okay. So I have a number of devices, so many number of devices in my office or in organization. I have a lot of devices. For all devices, we cannot connect it to a single hub or a switch. So what we can able to do it, we'll make it connecting like this. Okay, I connected this hub and this hub or this switch to this switch. Okay, so what will happen? Devices in this network can able to communicate in this network through like this. So, and it is become a single segment, means single network only. It's not a two networks, separate networks. There are single network only, single LAN communication, single network, or you can say single segment. Initially it is two segments, now it is become single segment. Within the LAN, they become single network only. Okay, this is called a extended star topologies. Extended star topology means we extend our star topologies from one simple network to next network and become a huge network now. Easy to scale, easy to troubleshoot, easy to configure, but additional cost is there. Why? Because of not only a wiring, also we are using a device here, and it is not so redundant. Okay, it's not so redundant. Why? Because of that the centralized device is down, total communication is stopped. If link is failure from one device to the hub or a search, no problem. Only that particular device won't work. A device is down, only that particular device won't communicate. But if this hub or a switch is down, total communication is stops. And it is scalable already explained. Guys, understand?
Yes, sir.
Yes, sir.
So we covered first topology,
Yeah.
link topology, mesh topology, and this.
Ring topology is again explain, sir.
You
Yes,
want
sir.
ring topology?
Again, sir, explain.
Okay.
No, sir.
Anti-clockwise, clockwise is not working.
Yeah, I will tell once. Ring topology. A device is connected to another device, and that device is connected to another device. And like this, the last device is connected to the first device. Like that, it form a ring. Like that, it will form a ring. It use certain algorithms or a programming protocols kind of stuff for the communication.
But if device is down, then ring device, ring topology.
Ring topology.
If device
Okay.
is
So,
down, then
yeah, if in case a device is down, for example, this device is down, what happened? A can able to communicate B, B to C, and communication stops here. It cannot communicate it to E. Okay, in the single ring topology. Easy to configure, but difficult to troubleshoot, difficult to scale. Okay, single ring topology, a link is down, a device is down, further communication is stopped. If you use double ring topologies, means two lines we are connecting, means two connection from one device to another device. So then maybe in a clockwise or anti-clockwise. So if link is down, further communication also there in another direction, another direction. If device is down, so then also from another communication, remaining communication is there in double ring topologies. But in single ring topology, you have to keep in mind it is simple to configure, but it is difficult to troubleshoot. If link is down or device is down, further communication will be stopped and difficult to scale. Means if you want to add one more devices, so what happens? So you have to reconnect it and reconfigure every device because you have to tell which path the devices should be communicate. That is a ring topology.
thank you.
Hello, sir.
Yeah, tell me.
Is clockwise or anti-clockwise in that will happen in single ring topology?
Yeah, Double ring means, and single ring topology means it is only one connection from one device to another device. So, and how it is functioned,
Okay.
how it is configured or programmed, designed, something, defined how to communicate in the devices.
Okay, sir. Thank you.
Right? This is a point to point. Point to point means you connect one device to another device. It's a point to point. For example, these are all point to point connections. See, A is connected to B, B is connected to C, A is connected to B, A is connected to C. These are all point to point. And if you see here also, hub and switches, A is connected to hub, B is connected to hub, or C is connected to hub or switch. This one, this is also point to point, means one to another one connected. That's a simple point in a point to point. But these point to point protocols, these words are actually applied for a WAN technologies. Means the routers to router connectivity is generally point to point connectivity. Point to point protocol PPP is a WAN technology. Okay, and you are connecting, like you have a one office and it is connected to another office through point to point connectivity. In case you have a main office and you have a different branch offices and you are connecting through this WAN connectivity, how you connect? So this is main office is connecting to branch office. It is point to multi-point connectivity. It is point to multi-point connectivity. I have a multiple branches. Then I'm connecting like this from one point to multiple branches. So New Jersey, I have a main office, and Hyderabad, Pune, Noida, okay, and Exton, Australia or Sri Lanka. I have another servers, another offices are there, and I will connect them through WAN connectivity. Okay, so this is point to point. This is point to multi-point connectivity. Hybrid topologies means any combination of two topologies called a hybrid. Means if you combine this mesh topology to the star topology, it is become full mesh topology. That is also a hybrid topology. Okay, guys, this is a backbone wire. Can you see a backbone wire like a bus topology? And to this backbone wire, other topologies are added. You can see there is a switch and there is a server, and switch is connected to some other machines, and that switch is connected to another switch, and there's some devices like some star topologies, some bus topology mixed up here. It is a kind of hybrid topology only. It's also called as tree topologies. So look like a tree means main, and there is some branches kind of stuff. So like that, it is, some people call it as tree topology. It is recently made up topology. It is okay. So it's mainly one backup line, and other devices are connected to this other topologies or devices connected to this backbone wire only. This is tree topology. So this is your physical topologies. Okay. So now what you will do, guys, take a break. Okay, so come back in a already 12:10. Take a break, 12:10, 15 minutes break.